All right, so now let's look at writing some formulas with transition elements as the metals here. Remember, our transition elements are in the group D here. And what happens here is most of them are positive 2 charge, because remember, when you're doing the electronegativity configuration, you're going 4s2, 3d something, okay, 3d whatever, 1, 2, 3, 4, up to 10. Because these are in a lower energy level, they're usually already plus 2, but sometimes electrons are lost in different energy levels, and it causes it to maybe have a plus 3 charge, and so forth. So really, if you think about it this way, to memorize these, from chromium over to copper is going to be plus 2 to plus 3. These all have a plus 2 to plus 3 oxygen state. Down below copper, we have silver, which is a plus 1 only, and then gold is plus 1, plus 2. Mercury is a plus 2. Lead is another one that you might see that can be a plus 2, plus 4. There's a lot of exceptions to chemistry, to the rules. So again, if you want to think of it this way, count over 1, 2, 3, plus 2, plus 3, plus 2. And the last one, zinc, is plus 2. So these are all plus 2, plus 3. So, knowing that, really, in the name, it's the Roman numeral that tells us the oxidation state. That's the purpose of the Roman numeral. It is not the number of cobalt or nickel or copper atoms. It is the oxidation state. So cobalt, we would think, oh, cobalt is one of those transition metals that have multiple oxidation state. Which one is it? It's a plus 2 charge. Oxide, minus 2 charge. Now again, once we have these two that are the same value, positive and negative, just opposite, same value, they just really cancel out into a CO. Okay? You can crisscross the charges, but remember, when we have the same, when we can reduce the subscripts, we go ahead and reduce it. Cobalt 3, again, cobalt 3 oxide. Again, it doesn't matter if you write it either way. This is technically the correct way, but we're going to crisscross the numbers, and that's going to come out to be. All right, why don't you guys pause the video and try the nickel 3 sulfide example. So looking at the periodic table, nickel's Ni, and it has a positive 3 charge. We know that from there. And the sulfide is, looking at sulfur minus 2, or 2 minus. Again, we're going to crisscross just the numbers. All right, and for the last one, again, I'm noticing all these IDE endings, so these are just binary between two elements. Copper, I see the Roman numeral there, so it has to be the oxidation state, phosphide. And again, I got the opposite, positive, negative, same number, so it's just going to really be, cancels those out, and at a 1-to-1 ratio, that is